Hello friends, welcome to Susan and John MathTube. This is lesson number 6 in the examination preparation series for first year engineering students. Again we continue with differential equation, and this time we will be learning the combination techniques and the homogeneous equation. And as always, the first and the most important question, and I'm sure you already know the answer, and I hope you're doing all these things. So let's start with the video. So it's product combination. So look at this. We learned 4 types. Anyway, type 0 is the right side being 0, and type 1 means the right side will be an exponential function, and type 2 the right side will be sine or cosine, and in type 3 we have polynomials on the right side. Now you can look at the title, product combination. So we are going to combine type 1, type 2, type 3 as a product taken 2 at a time. So the possibilities are e power ax multiplied by sine or cosine, or e power ax multiplied by a polynomial, or the last possibility sine or cosine multiplied by a polynomial. The first 2 cases are very easy, and the last one we have to manipulate a little bit so that we will be able to find the solution. So with that, let's start the topic. Please note the first question. Solve the differential equation d square y by dx square plus 3 into dy by dx plus 2 times y equal to e power 2x into sine x. So look at this. Let's call this as type number 4. And type number 4 means the right side will be a product in which we combine type 1, type 2, or type 1, type 3, or type 2, type 3. Anyway, you can see that the right side is a product, and it is a combination of type 1 and type 2. Okay, and the first thing to do, as always, convert this into capital D. So d square y plus 3 capital dy plus 2y is equal to e to the power 2x times sine x, and that gives us d square plus 3d plus 2 of y is equal to e to the power 2x into sine x. Now look at this. What's the first thing to do? We already learned in lesson 3, 4, 5 what to do first. Yeah, auxiliary equation. And the auxiliary equation is m square plus 3m plus 2 equal to 0. Now use a calculator and find the values of m, that is minus 1 comma minus 2. So the roots are real numbers as well as distinct. So the complementary function is y equal to c1 e to the power minus 1x plus c2 e to the power minus 2x. Yeah. So up to this, it's the same process. Now what are we supposed to do next? Yeah, the particular integral. So 1 by the operator. What's the operator? d square plus 3d plus 2 of the right side. Once more I'll tell you, 1 by operator of the right side, that is e power 2x into sine x. Now look at this. Here what we do is, we will take this e to the power 2x and keep it outside the operator. So we get e to the power 2x 1 by, okay, now listen. So what we do is we do 1 by d plus 2, the whole square, plus 3 into d plus 2 of sin x. So I hope you understood the method. When we have a combination of exponential and sine or cosine or polynomial, just keep this exponential part outside the operator here. And who is along with x? 2. So you replace d with d plus 2. And that's it. Now simplify it. So e to the power 2x 1 the whole divided by d square plus 4d plus 4 plus 3d plus 6 plus 2 of sin x. And that is equal to e to the power 2x 1 the whole divided by, that is d square plus 7 into d plus 10 and then 12 sin x. Okay, now that's it. Now you can handle this problem by yourself. Look at this. We learned type 1, type 2, type 3. Isn't this type 2? The pi of type 2? Exactly. So what do we do next? Okay, we have sin x. That means the argument is 1 into x. So 1 squared gives me 1. And I take negative of that, I get minus 1. So in the next line, what I do is, we write e to the power 2x 1 by, I replace d square with minus 1 plus 7d plus 12 of sin x. And that is equal to e to the power 2x and 1 by, so tell me what is, 7d minus 11, that is 7d plus 11. So we get 7d plus 11 of sin x. And I hope you're really good in type 2. In type 2 what we do is we multiply by the conjugate. So 7d minus 11 by 7d plus 11, and we multiply this by 7d minus 11. And you know the intention. E to the power 2x 7d minus 11 the whole divided by, we want 49d square minus 121 of sin x. Again replace d square with minus 1. Now I am not going to explain the reason because you know the reason. So e to the power 2x 7d minus 11 the whole divided by minus 49 minus 121 of sin x. And that's equal to, this will be 130, 30 plus 40, 70. So e to the power 2x by minus 170 and then 7d minus 11 of sin x. This part is really easy because you're already familiar with type 2. So we're going to get e to the power 2x by 170, and I'll put that negative here. And what is the derivative of sin x? Cos x. Minus 11 into sin x is 11 into sin x. So that's it, but don't forget to write the general solution, that is y is equal to cf plus pi. I always skip the last part because it's obvious. Okay, now let's try one more question. D square y by dx square. So you can write the question, solve. minus 4 into y equal to e to the power x into sine 2x. So this is clearly type 4. Type 4 because it is a combination, a product combination. This is a product and combination of type 1 and type 2. So the first thing to do, convert this into capital D and then take common, and finally auxiliary equation, that is m square minus 4 equal to 0. So m equal to plus or minus 2. So the roots are real and distinct. So the CF is y equal to c1 e to the power 2x, c2 e to the power minus 2x. Okay, now the PI. So I'll start from this corner. We're going to get 1 by, what is the operator? Yeah, d square minus 4 e power x and then sine 2x. And remember, the method for sine and cosine are the same. So what's the method? It's a product. So what we do is we will target this part first and you keep it outside. So we get e to the power x and then 1 by, who is along with x? 1x. So it is like d plus 1 the whole square minus 4. Yeah, and that is equal to e to the power x 1 by, simplify this, you can do that in your mind, d square plus 2d plus 1 minus 4 of sine 2x. Now I can leave at this point because this is something very easy for you. Type 2, this is clearly the particular integral for type 2, it's the same thing. So what we do is, what is the argument? 2x. So we write 2 and then square that quantity and then take negative of that quantity and we replace d square with minus 4. So let's do that. Equal to e to the power x 1 by minus 4 plus 2d minus 3 of sine 2x. And that's equal to e to the power x 1 the whole divided by 2d minus 7 of sine 2x. Now what to do? That will be e to the power x and we multiply by conjugate. So 2d plus 7, 2d plus 7 and then here 2d minus 7 of sine 2x. That's equal to e to the power x 2d plus 7 the whole divided by of sine 2x. Again the same thing, e to the power x 2d plus 7 of sine 2x the whole divided by, we will replace this d square with minus 4 just like we did here. So we get minus 16 minus 49, that will be minus 65 and in the numerator we just open the bracket. So we are going to get minus e to the power x by 65 and 2 into, what is the derivative of sine 2x? Yeah, 2 cos 2x plus 7 into sine 2x. So that's it. Now most important part, the general solution. I'm skipping this step regularly because I know you're smart. So GS will be CF plus PI. In the exam, don't forget to add them up. Now you can try one more question. Please write solve d square minus 2d plus 4 of y e power x into cos x. The same process. I'll give you a hint for pi. So pi is 1 by operator e power x into cos x. So we take this to this side. So we get e power x 1 by, when I put 1, d plus 1, I'll get d plus 1 the whole square. D square plus 2d plus 1 minus 2 into d plus 1. So minus 2d minus 2 plus 4. And that gives us e power x 1 by, so this 2d and 2d will get cancelled, and 5 minus 2, so we're going to get d square plus 3. And now this simply type 2. So we are supposed to replace d square with minus 1. So the answer is, that's it. You can try it yourself. So remember, for cos and sine the method is same. Now the next one, solve. And remember, you have to work out a lot of questions. You may feel you're doing the same process again and again and again. But remember, if you want to excel in your exams, even for the students who are trying for pass mark, practice is very important. If you practice, it's guaranteed you're going to get good marks. Yeah. So please write the next question. Solve d square minus 2d plus 1 of y is equal to x square into e to the power 3x. So the same process. So first auxiliary equation, that's going to be m square minus 2m plus 1 equal to 0, implies m equal to 1 comma 1. So CF is y equal to c1 plus c2x times e to the power x. Okay, now the pi is 1 by the operator. I can see that this operator is d minus 1 the whole square, isn't it? A square minus 2ab plus b square, yeah, of x square into e power 3x. Now look at this. This is type 3. And in type 3, what we do is we keep the exponential here. So we are going to get 1 by d plus 3. We have to replace d with d plus a minus 1 the whole square of x square, and I have to keep this over here. And this is equal to e to the power 3x into 1 by d plus 2 the whole square of x square. Okay, now look at this. This is actually the particular integral of type 3. And the process is very easy, but you had to create 1 in the denominator. And for that, I'll take 2 outside, because I told you d square, d and constant. So the superior person is d square, and just beneath him d, and finally constant. So if you have d and c, then constant should go outside. So 1 plus d by 2 the whole square of x square, and that is equal to e to the power 3x. And if you simplify, you'll get 1 by 4, and you simplify further, you get 1 plus d by 2 the whole power minus 2 of x square, and that is equal to e to the power 3x by 4, and then you have to expand this. 1 minus 2 into x, but x is d by 2, plus 3 into x square, and x square is d square by 4. And I am going to stop with this. What is the reason? This is a polynomial of degree 2. And that means the third derivative onwards, the answer will be equal to 0. Now let's just distribute this here, here and here. So we get e to the power 3x by 4 in bracket 1 into x square minus this 2 and 2 will get cancelled, and derivative of x square is 2x plus 3 by 4 into 2, because second derivative of x square is 2. So that's it. Now one very important problem. It's extremely important. And before we start, we have to discuss about the Euler's value. This is something which you learned in complex numbers in class 11. So if you ever see e to the power I theta, you should understand that this is actually cos theta plus I sin theta. That means real part of e to the power I theta is, what is the real part of this complex number? The part without I. And the imaginary part of e to the power I theta is equal to sin theta. Imaginary part means the quantity which is along with I. Now with this result, we will move on towards the next type, that is the combination of type 2 and type 3. Okay, one more thing. If you have e to the power I into 5x, that will be cos 5x plus I sin 5x. That means real part of e to the power I 5x is cos 5x and imaginary part will be sin 5x. So now write the question. Solve the differential equation d square plus 4 of y is equal to x times sin x. So as always, let's start. So what's the first thing to do? Auxiliary equation, that is m square plus 4 equal to 0. Use a calculator or otherwise solve it. We'll get m equal to 0 plus or minus 2i. And that implies the complementary function is y is equal to e to the power 0x c1 cos 2x plus c2 sin 2x, and e power 0 is 1, so you'll be left with this. Now the pi. So the pi is 1 by operator. What's the operator? Yeah, of the right hand side. And what's the right hand side? X into sin x. Now look at this. This is clearly type 4 because it is a product and a combination of type 2 and type 3. So what we do in such cases is we write 1 by d square plus 4, and I'll keep this x as such. Now look at this. Just a minute ago I told you sin theta is imaginary part of e power I theta. So instead of this sin x, I'm going to write imaginary part of e power ix. And from the next step onwards, I'll keep on writing imaginary part here so that we don't forget. 1 by d square plus 4 of x into e power ix. That's it. Now it looks like the previous problems. We have an exponential function here. But remember, you have to keep on writing imaginary part, imaginary part, imaginary part till the end. So what will be the next step? I'll take e to the power ix outside the operator. So I'm going to write e to the power ix, and 1 by d will be changed into d plus I plus 4 of x. Okay, so that is equal to imaginary part of e power ix, and then let's expand that 1 by a square plus, that is d square plus 2id plus I square. I square is minus 1. So this is equal to imaginary part of e power ix. Now if you look at this part, you will understand that this is nothing but type 3, or the particular integral of type 3. So 1 by d square plus 2id plus 3 of x. And the most inferior person in the group is 3, so we have to take 3 outside. So we take 3 outside, you end up with 1 plus d square plus 2id by 3, and that is equal to imaginary part e to the power ix 1 by 3, and 1 plus d square plus 2id by 3 the whole power minus 1 of x. It's an infinite series, but the polynomial is of degree 1. That means second derivative onwards the answer will be 0. First derivative of x is 1, second derivative onwards the answer is 0, 0, 0. So this is the same as, and I hope you remember, 1 plus x the whole power minus 1 is 1 minus x plus x square minus dot dot dot. So this is equal to imaginary part of 1 by 3 e power ix, and this will simplify to 1 minus d square plus 2id by 3. Actually plus minus it goes to infinity, but I'll stop with this term. Okay, now what we do is we distribute this x. So we get imaginary part of 1 by 3 into e power ix, and x goes inside, minus second derivative 0 plus 2i derivative of x is 1 by 3, and that is equal to imaginary part 1 by 3, what is e power ix, and then x minus 2 by 3i. Okay, now you have to be extra careful. That is imaginary part of 1 by 3 into, now we multiply. If you want, you can skip this step if you can do that in mind, but I'll strongly recommend you do this. So we get x into cos x, then minus 2 by 3i into cos x plus I x into sin x, and I square is minus 1, so that becomes plus 2 by 3 sin x. So that's it, we have got the last step. We want the imaginary part. Imaginary part means the coefficient of I. So we get 1 by 3 into who is along with I. So that will be minus 2 by 3 cos x plus x into sin x. Now if you want, you can take LCM, you'll get 1 by 9, and here you'll get 3x sin x. Anyway, that's it, that's the end. And this type of question is very important. You can try one more question of the same type. I'll give you the question. Solve the differential equation d square minus 1 of y equal to x square into cos x. I'll give you a hint, and if you have trouble, please feel free to mail me. You can check our website and you can contact me directly in the messenger, or feel free to comment or email me. So the particular interval is 1 by d square minus 1 x square into cos x. Now what will you do with this cos x? This is a product combination of type 2 and type 3. Okay, now what we do is very important. We write cos x as real part of e power ix. Yeah, now the job is done. So real part, and I'll take this, I'm skipping steps, e power ix, and I replace d with d plus I. Now I hope you'll be able to handle this. Okay, now let's move on to another very important type and one of the most repeated question, that is the Cauchy-Euler equation. So this is extra important, and you can check the past year's question papers. In most of the question paper, you will find a question related to Cauchy-Euler equation. Even when they don't ask questions based on the first part, that is type 1, type 2, type 3, type 4, they always tend to ask questions based on Cauchy-Euler equation. And you might have heard the name homogeneous equations. They are both same. So I'll tell you the pattern. It's very easy to identify. The earlier equations had constant coefficients for d, d square, etc. In such problems, d will be accompanied by x, d square will be accompanied by x square, and d cube will be accompanied by x cube, and so on. So I'll give you an example, and as always, let's learn the process while solving the equation. And don't forget what I told you in lesson number 3. We are just learning a technique. Technique is nothing but shortcuts. You are not going through the logic or the proof or how these things comes. As an engineering student, you must learn how to find the solution whenever you get locked up in differential equation in your applied subjects. And that is exactly what we are going to do. And if you look at some of your books, you might find the proof behind it. Anyway, I'll give you the method. So the question goes like this. Solve the differential equation x square d square y by dx square minus x into dy by dx minus 3y is equal to x square into log x. So that's obvious. It is Cauchy-Euler equation, because in all the other equations which you learn in first year, you have constant coefficients. So as always, I'm going to convert this into capital D. So it goes like this. If you want, you can skip this step and you can do these things in your mind, and that will be x square d square minus x into d minus 3 of y is equal to x square into log x. So as I promised, you saw xd, x square, d square, etc, etc, etc. Now for the method. So what you do is, you assume x in every problem, you assume x equal to e power z, and the inverse substitution, z equal to ln x, log x, and you put theta is equal to d by dz. X into d is equal to theta, x square into d square is equal to theta into theta minus 1, and x cube into d cube is equal to theta, theta minus 1, theta minus 2, etc, etc, etc. In some books, instead of theta, they use small delta. In some other books, instead of theta, they use d dash. Anyway, you can refer any book you like and follow the notation you like. Anyway, I'm used to this theta because I learned like this long back. So this part is for the left side and this part is for the right side. So theta into theta minus 1 and theta stands for derivative operator. Minus theta minus 3 of y is equal to x. Now for the right hand side, the substitutions are over here. E power 2z, because when you square that you get e power 2z into z. Okay, now let's focus on this. Just imagine theta is our d. We learned in type 1, type 2, type 3, type 4, we had capital D, right? That is our theta. Now simplify this, you get theta square minus theta, that will be 2 theta minus 3 of y equal to z into e power 2z. So look at this, just imagine theta is our d, and instead of x we have z. So as always, auxiliary equation, m square minus 2m minus 3 equal to 0. Use a calculator, we get values for m, and that is 3 and minus 1. Now one warning, as seen in many answer papers, the CF, what's the CF? Can you guess? C1 e to the power 3, is it x? No. That's very important. If you said x, please be aware of it, because in many answer papers people tend to write x. There is no x. Once we substitute, that x disappears. Okay, and that is y is equal to c1 e to the power z the whole cube plus c2 1 by e to the power z. That is y equal to c1. Let's look at the previous page. What is e power z? X. So this is x cube and this is by x. So this is our complementary function. Now for the particular integral. The particular integral will be 1 by operator minus 3 and z into e to the power 2z. Now, is it type 1 or type 2 or type 3 or type 4? It is a product combination of type 1 and type 3. So what's the method? Yeah, you take this outside the operator and then replace d with, theta with, there is no more d, so that is theta plus 2 the whole square minus 2 into theta plus 2 minus 3 of z. I hope you are able to understand this. If not, please email me, I'll help you with it. So 1 by, expand this, theta square plus 4 theta plus 4 minus 2 theta minus 4 minus 3 of z is equal to e to the power 2z 1 by, these two will get cancelled and we get theta square plus 2 theta minus 3 of z. Now it's obvious this is type 3. So how do you deal with type 3? You have to take the inferior person outside and create. Okay, so it goes like 1 minus theta square plus 2 theta by 3 of z, and that is e to the power 2z by minus 3, 1 minus theta square plus 2 theta by 3 of z, here whole power minus 1. Now look at this, 1 minus x the whole power minus 1. This is equal to 1 plus x square plus dot dot dot. But this is a polynomial of degree 1. So theta of z is equal to 1. Theta square means the second derivative will be equal to 0 and so on. So we need only one term. So e to the power 2z by minus 3, 1 plus theta square plus 2 theta by 3. If I write the next term, I'll get whole square, and whole square means we'll have the fourth order derivatives and second order derivatives onwards, and we don't need that. Now that's it. You apply distributive property and open the bracket. So e power 2z by minus 3, z plus second derivative is 0, first derivative is 1 by 3. And one more step and I'll stop. This is minus 1 by 3. This is x square, and z means log x plus 2 by 3. If you're wondering where this comes from, in the beginning I told you these substitutes, so we just resubstitute them. So maybe you understood this method and maybe not. So let's make things very clear. X square d square minus x into d plus 1 of y is equal to log x. So the method is very simple. Whenever you have an equation like this, identify it is a Cauchy-Euler equation. And once you identify, for all problems the method is similar, put x equal to e power z. And log x is equal to z. And this is for the right hand side. And next thing, let theta be the derivative operator with respect to z. Then x into d will be equal to theta, x square into d square will be equal to theta, theta minus 1, etc., etc. So we substitute and we get theta into theta minus 1 minus theta plus 1 of y is equal to, now the substitute for the right side, that is z. And if you open the bracket and simplify, you will get theta square minus 2 theta plus 1 of y is equal to z. Now look at this. This is the same as d square minus 2d plus 1 of y equal to x. It's the same thing. But instead of d, we have theta, and instead of x, we have z. So as before, the first step, auxiliary equation. That is m square minus 2m plus 1 equal to 0. M equal to 1 comma 1. And that implies the complementary function is y is equal to c1 plus c2z. Please be aware of this, it is not x, into e to the power z. And we have to convert this. So c1 plus c2, now look at this, z is actually log x. So this is log x, and e to the power z is x. So outside we have x. So this is our CF. Now for the PI, we write 1 by operator of z, and this is actually 1 by, I can see this being theta minus 1 the whole square, and it's the same as 1 minus theta the whole square. That's these two are equal because a minus b the whole square and b minus a the whole square are same. So we get 1 minus theta the whole power minus 2 of z, and that's equal to 1 plus 2 theta plus 3 theta square. Wait, we don't have to write much because the polynomial is of degree 1. So when we take it inside, we get 1 into z, that is z, plus this is the first derivative, that will be 2 into 1, and that is equal to z plus 2. but z is log x plus 2. Now you write the general solution, that is CF plus PI. I'm going to wind up this video right now. In the next video, we will discuss questions from your past year's question papers based on capital D. So till then, bye.